Hello everybody. Today I can prepare for my exponents test by practicing. So we're going to talk about every type of question that you need to know, and that's what we're going to do. The more you practice, the better you're going to be. So let's get started. So there are two ways to do this question. We're going to start off with multiple choice strategy. As I told you, if these are multiple choice questions, I would rather you use multiple choice strategy. So how would you do this using multiple choice strategy? Well, I would do 10 store as x, 15 store as y, alpha 1 to access y. You have to just do that once because we have to assign values for x and y in order for this strategy to work. I type in the original problem. To type in the fourth root, I hit 4, whatever the root is, then math, and then option 5. 81x squared alpha 1 y to the 5th. I get 280.04 or whatever. Now I'm going to type in each choice and see which one matches up. 3x to the power of 1/2 y to the power of 5/4. Is that the same thing? Yes, therefore that's my answer. You can go through all 4 choices to be sure. For time now, I'm just going to do it that way. Now, and if you want more on this, you can watch the multiple choice strategy with variables video or the fractional exponents regions practice video. I go over some examples specifically in this topic for multiple choice strategy. Now, if I'm doing this question using doing it by hand, we have our song to help us. So let's hear our song. Common Core Algebra 2 songs, exponents, boom.
Radicals of fractional exponents. Get rid of parentheses. Negative exponents of fractions. Clean it up and be.
Yeah. Radicals of fractional exponents. That's the first step. Do I see a radical? Yes. So I'm going to rewrite it as a fractional exponent. The fractional exponent is always the power over the root. Get rid of parentheses. Everything gets the 1/4 power. 81 gets the 1/4 power. Now when I'm raising a power to a power, I multiply the powers. 2 times 1/4 is 2/4 or 1/2. 5 times 1/4, 5 times 1 is 5, over 4 is 5 over 4. Negative exponents are fractions. Clean it up, MD. So that MD is M for multiplication. There's no multiplication I need to do. D is for divide. There's no division I need to do. But I also then want to try to see if I can put it back in a radical. And 81 to the 1/4, you can either do the 4th root of 81, or you can type in 81 to the power of 1/4, and you get 3, because 3 times itself 4 times is 81, and that's how you would come up with that answer. So number 2 is the same type of thing. Again, I would definitely do multiple choice strategy for number 2, but we're going to skip a little bit ahead here just because we have more examples later that are open response. So let's just go over number 7 now. No multiple choice strategy because it's not multiple choice. Radicals are fractional exponents. I see a radical, so I'm going to rewrite it as a fractional exponent. There is no power, so it's 1, and the root is 3. Get rid of parentheses. Everything inside gets it, and whenever I raise a power to a power, I multiply powers. So negative 6 times 1/3 is negative 2. 12 times 1/3 is 4. 27 to the 1/3 power is 27 to the 1/3 power. And z to the ninth of the 1/3 is -3. For the integer, you're not multiplying by 1/3, you're raising to the 1/3 power. Negative exponents are fractions. Use a different color. I see negative exponents, so I'm going to go through each thing, and I'm going to move what's being raised to the negative power. Is x being raised to the negative power? Yes, so it moves to the bottom. Is y being raised to the negative power? No, so it stays on top. Is 27 being raised to the negative power? No, so it stays on the bottom. Is z being raised to the negative power? Yes, so it moves to the top. Clean it up, MD. The only thing I can clean up is 27 to the 1/3 power. Ideally, you understand that the 1/3 power is the cubed root, and ideally you know that the cubed root of 27 is 3. But I can also just go to my calculator and type in 27 to the 1/3 power and get 3. So my answer is y to the 4th, z to the 3rd, over 3x squared. We spent, probably like a week on these types of questions because they build, and build. You can use multiple choice strategy if it's multiple choice. And if you just follow your song, radicals, parentheses, negative exponents, clean it up, you should be good. So I'm just going to go over the odds in this review sheet just because, the goal is for you to do the evens on your own. And you can always go back to the videos on each specific topic. So if you want to practice this more, I would go to Fractional Exponents Regions Practice video, but you could really watch Given Radicals or Given Fractional Exponents since they all build. So this is from the Exponential and Logarithmic Graphs lesson. What you need to know about that, you know what, let me pause it and pull it up quick. So this is basically what you need to know about exponential graphs and logarithmic graphs. You need to know what they look like. You need to understand that they have asymptotes. Exponential has a horizontal asymptote. Logarithmic has a vertical. It's getting closer and closer, but never touching. Same thing here, so you can't tell it exactly by the calculator picture, but it's getting closer and closer, but never touching. Again, we talked about the asymptote. Exponential is horizontal, logarithmic is vertical, it's opposite. Every exponential, every non-translated exponential passes through 0, 1. Log is 1, 0, the opposite. The domain for exponential is all real numbers. The range for this one is all real numbers, the opposite. The range for this one is positive real numbers. The domain for this one is positive real numbers, the opposite. Because exponential and logarithmic functions are inverses of each other. That's everything that you need to know. It's a conceptual thing. So for this one, it says if a function is defined by this equation, so it's a log graph. Which graph represents the inverse? Well, the inverse of log is exponential. Because it's a positive base, it's a base 4. Essentially, I'm looking for 4 to the power of x. Basically, I'm just looking for an exponential growth. Choice 1 is your exponential growth. You need to understand that exponents and logs are inverses of each other. You have to know that an exponential graph looks like this, and you need to know that a logarithmic graph looks like this. All right. Number 5 is another question based on that, but we might as well talk about it. Which statement is false? So you need to know that a log graph passes through 1, 0, has an asymptote. It looks something like that. So let's go through each choice. The asymptote has an equation y equals 0. Nope. It has an equation x equals 0. Y equals 0 is a horizontal asymptote. An exponential graph would have that. The graph has no y-intercept. That's correct. It never hits the y-axis. The domain is positive reals. Yes, the x values start at 0, but not including 0, and go on forever. The range is all real numbers. Yes, yes. It goes on forever in both directions. Choice 1 is false. Could you type in log base 6x and look at it? Yes. I'd rather you just know what the log graph looks like, but if you're taking a test, it's not a bad idea to go to y equals, to type in log base alpha window 5, log base 6x, and that way you can kind of look at this to help you, but it's more important that you understand what it looks like. And again, it's not a perfect picture that it gives you. You need to understand that it's getting closer and closer to the x-axis, I'm sorry, the y-axis, but never touching it. We did these. All right, exponential equations. In any exponential equation, the first step is to isolate the base. So what's the base? What's being risen to the power? X's. It's not 3x. 3 isn't touching the 2/5. Only the x is touching the 2/5. If there was parentheses around it, then the whole thing would be the base. But the base is x. So I want to get x to the 2/5 by itself. Whenever you're isolating, this really goes back to 7th grade, we're always adding or subtracting first and dividing last. And if you want more practice with this specific type of question, you can go to constant exponential equations. So I'm adding the 11. Dividing by 3. To isolate, I add or subtract first, divide last. Now, because this is a constant exponential equation, there's a number in the exponent, there's no variable. To get rid of the constant exponent, I raise both sides to the reciprocal power. Reciprocal means flip. I have 100 to the power of 5 over 2. 100 to the power of 5 over 2 is 100,000. That's your answer. For all exponential equations, we isolate first. For constant exponential equations, we raise both sides to the reciprocal power. So I'll jot that down. Raise both sides to the reciprocal power. My guess is the next type of question we're going to go over is a variable exponential equation, and it's a word problem. So I'm going to go over number 12 just since it's a little more challenging than number 11. This is taken from exponential equations word problems. So if you want to practice this type of question more, you want to watch the video for exponential equations word problems. It's giving me an equation, b of t equals 2500, 1.075 to the power of t. We always want to list the variables to make sure we understand what they represent. The balance of the account is b of t, and t is years. So there are 3 separate questions. A, how long will it take for Juliet's money to reach $4,000? Well, $4,000, is that years or is that balance? That's balance, so this is b of t. So for A, I'm going to replace b of t with 4,000. So what I'm going to do first is I'm just going to set up each of them, and then we'll worry about solving that after the fact. How long will it take for Juliet's money to double? Well, this is indirectly giving me a piece of information. Money to double. Is this more related to years or balance? Balance. If her money is doubling, then her balance will be her initial amount times 2, which would be the balance. So the balance would be 2,500 times 2 equals 1.07 equals, I'm sorry, I missed something there, equals 2,500, 1.075 to the power of t. C, how long will it take for Juliet's money to increase by 50%? Well, again, it's not giving me years, it's indirectly giving the balance. If it's increasing by 50%, I do 1 plus 0.5, which is 1.5. So if her money is increasing by 50%, and I'm multiplying her balance by 1.5. So all these are giving me the balance, they're just giving to me in a different way. So here, the balance is 2,500 times 1.5 equals 2,500, 1.075 to the power of t. Now, to solve these, there's two methods. Method 1, y1, y2 intersect. So let's do that for the first one. y1, 4,000. y2, 2,500, 1.075 to the power of t, or in this case x. I always start with zoom 6. Now, since I have these big numbers, 4,000, 2,500, I know it's not going to really give me much, but I'm going to try it anyway, and I see it gives me nothing. So if zoom 6 gives you nothing, then go to zoom fit, which is zoom 0. This is what your calculator thinks you want to see. It may or may not be right. It may or may not be perfect. It's definitely better than what I had. And you know what? That looks pretty awesome because I'm looking for the intersection point. So now that I see the intersection point, I hit second trace, option 5, intersect. Second trace, option 5. My little spider comes up. I use the right tab button. I move it over to the intersection point. Enter, enter, enter. The x value is what I'm looking for. It says to the nearest tenth of a year, so that would be 6.5. And as far as the work you're showing for that, y1, y2, intersect. If it says to solve algebraically, you will not get full credit for this. Again, if it says to solve algebraically, you will not get full credit. If it does not say to solve algebraically, then you will get full credit as long as you write y1, y2 intersect. Now, let's do the second one algebraically. It's an exponential equation, so my first step is to isolate by dividing both sides by 2,500, and essentially those 2,500s cancel. Now that I'm isolated, since I have a variable in the exponent, I'm not going to do the reciprocal power, I'm going to do the log of both sides. So I have log 2 equals log 1.075 to the power of t. The variable comes in front, the exponent comes in front, and then I would divide that away. Cancels. Alpha y equals enter, log 2 over log 1.075 to the nearest tenth, 9.6. You could have done it with y1, y2 intersect, and you will have gotten the same thing. Which one do I want you to do? I really want you to know how to do both. I mean, I guess algebraically is better, but this y1, y2 intersect strategy is an amazing strategy. I want you to be comfortable with it. I want you to be able to use it. I'm not going to solve C for you now. I'll let you do that on your own for practice. And that's basically what's going to be in your test. Practice, make sure you know how to do everything that's on here. Go back to the earlier videos, go back to the earlier keys, use this key, use this video. I mean, I can't give you any more resources than I already am. Please utilize the resources. If you do, I think you'll be in good shape. I hope you choose to practice, and I hope everybody has a great day.